Hi everyone, welcome to Go Classes. Before we start, please let me know, is the audio, volume, video, is everything clear? Please let me know. So, in this session, we are going to discuss discrete mathematics, all questions from GATE 2023 exam. All the questions I will discuss. There were six or I think total 6 questions were in the GATE exam from discrete mathematics. A lot of questions. So this year actually from DBMS only 3 questions were there. From compiler design only 4 questions were there, but from discrete mathematics almost 7 questions are there in the GATE exam. In the GATE 2023 almost 7 questions, and all the questions are very beautiful questions. Okay, so we will discuss the solutions, we will discuss now. So before we start, please let me know, audio, video, volume, is everything clear? Then we can start. So this is the session, GATE 2023 analysis part 3, discrete mathematics. In this session we will discuss the discrete mathematics questions of GATE 2023. Let me introduce myself. My name is Deepak Poonia. I have completed my MTech from Indian Institute of Science, IISc Bangalore, and many times I have secured top rank in the GATE exam, like All India rank 53, 67, All India rank 206, All India rank 256, etc. Okay, so now let's start now. Also, I want to tell you that for the GATE 2023, the analysis and solution part 1 and 2, those are available on the Go Classes YouTube channel. The link is already available in the description. Okay, so this is part 3. As you can see, this is part 3. In this part we will discuss the discrete mathematics questions, but the part 1 and part 2, those are already available on the Go Classes YouTube channel, and the link you can find in the description. So you can check the description for the part 1 and part 2. Also, you can join Go Classes Telegram group for doubt discussions. For all your doubt discussions, you can join Go Classes Telegram group. You can join. Okay, the link is again in the description. So check out the description. Definitely, you will find basically many useful links you will find, like Go Classes Telegram group. Also, the complete analysis of GATE 2023 paper. All the questions, basically the solution, the detailed solution of all the questions, that you will find in the description. So check out the description. Now let's start. Okay, so let's start now. This is in this session, as I told you, this is GATE CSE 2023 discrete mathematics analysis and solution session. Let's start with the first question. This was a beautiful question from the first order logic. Okay, there was one beautiful question from the first order logic. One very nice question was there. So let's discuss that question first. First order logic, GATE question, GATE 2023 question. This was the question. Do you remember that? This question, do you remember? So actually, let me tell you what was there. This expression was given to you. Okay, in the question, the given expression was this. This expression was given that for all x, what the question is saying that. Okay, so for all x here, this was actually about natural numbers. So the domain, let me tell you, the domain was set of natural number. So just give me 5 seconds. Okay, just give me few seconds. I will come back. Let me connect my laptop to the charger. Then I will discuss this question. Okay, so let's start now. So in this question, the first order logic question we are discussing. Okay, in this GATE 2023, the first order logic question we are discussing. This question was there. So let me write the complete question. In this question, the domain was given to you, that was set of natural number. This domain was given to you 1, 2, 3. This domain was given to you, and this expression was given to you. So let's call this expression E. Let's call this expression E. And the expression was like this, that for every x, if this px is satisfied, then there is some y, then there is some y such that qxy is satisfied. Okay, so this question was there, right? And some options were there. We will see all the options one by one and what the question was asking. So there were some options, like there was one option where you have for all x, for all y, qxy. This option was there. Okay. Another option that was there, that is, you can see there exists y for all x, and you have that px implies qxy. There was another option. There were some other options, as you can see. There was another option, there exists x, px, and there exists y, qxy. There was another option, there exists x, px, and for all y, qxy. Okay, so this question was there. Now let's discuss each option one by one. What I am going to do, each option I will discuss one by one. Each option I will discuss. And actually what the question was asking, the question was basically asking which option will imply the given expression. Okay, so so in this question, actually the question is asking, let me tell you what the question was asking. The question was asking which option implies the given expression. Which option implies given expression? Implies the given expression. Okay, so this was the given expression. Which option implies the given expression? So remember, the question was asking which option implies the given expression. Okay, which option will imply? So we have to see in this direction, that will this imply this? Will this imply this? So in this direction we have to think about. Okay, is this clear? So this is the question. I hope this question is clear. One silly mistake that is possible in this question, one silly mistake is, many students were thinking, there were some students who told me that they were thinking, sir, that we thought that in this direction the question is asking. Okay, this was a silly mistake. Many students were thinking that in this direction question is asking, but question is not asking in this direction. Did you make this silly mistake? Please let me know. Did you make this a silly mistake? Did you make? This is a silly mistake. This is a silly mistake, that if you are thinking that this expression implies which option, this expression, will it imply this option, this option? There is option number 3, there is option number 4. So this option will imply which option? This is a silly mistake. This is a clear silly mistake. This is a mistake that many students have made. I think at least some students have made this mistake. Some students told me that they have made this mistake, that they were thinking that given expression will imply which option. But actually the question is asking that which option will imply the given expression. Okay, this expression, will it imply this? This option, will it imply this? So the question is in the reverse direction. Which option is going to imply? Remember this point. Clear? Okay, which option? As I told you, which option implies given expression? This was the question. Now let's see this question one by one. So let's see the first option. The first option, let's discuss for all x, for all y, qxy. Now, does this imply E? This is the question. Does this option, does it imply E? This is what we have to check. We have to check that this expression, this is your expression, will it imply E? Does this imply E? Means if it is true, then can I say E will be true? The given expression will be true. Okay. Before that, let's understand the given expression. Before we solve this question, we have to understand the given expression. So let's understand the given expression first. Then we will solve the question. So you can see that in this question, let's discuss. So what is this given expression saying? Let's understand this given expression. So this given expression is saying that for everyone you are saying that if you have this property P, then there is someone such that someone is for you. Okay, so I can say that what this question is saying, the domain is set of natural number. You know that domain, your domain is set of natural number. This is your domain, that 1, 2, 3 and so on. This is the domain is set of natural number. And you are saying that for everyone we are saying that if you satisfy the property P, then there will be someone who will help you. Okay, there will be someone who will help you. See, actually you can understand like this. Let me assume that P means padhai. Okay, let's assume that if you study, then God will help you. Okay, let's assume Px means X studies, X works hard. So if you work hard, let's assume that you are working, okay, X is working hard. So let me assume this. So let me assume that Px is X is working hard. If X is working hard, then someone will definitely help. Okay, then someone will definitely help. So this is what we are saying, that this Qxy means this, I can say this Qxy means Y helps X. Okay, so let's assume this Qxy means Y helps X, something like that. Okay, so you can understand like this. So what this option is saying, this statement, this expression, what this expression is saying, this expression is basically saying that for everyone we are saying, if you have property, okay, if any element has property, for example, let's assume this is your domain. If any element, okay, if A has P, if A has property P, then some there is some B, such that Q A comma B will be there. Okay, and this you are saying for all elements. This statement you are saying for all elements, that if you have property P, and this you are saying for all A. For all A you are saying, for all the natural numbers you are saying, for all A belonging to N. So this is the given expression. Now let's see whether the first option is correct or not. What is the first option? Let's see the first option is correct or not. So the first option that you have, just give me a second. Okay, sorry. So yeah, just please wait. Yes, so what I'm saying, okay, let's see the first option. The first option is for all X, for all Y, Qxy. Now you can easily see that this will definitely imply E. Why this will definitely imply E? Because if this happens, then definitely E will happen. If this is true, if this is true, then definitely E will be true, right? If this is true, then definitely E will be true. The reason is very simple. What is the reason? Let me tell you. The reason is this, that if this is true, what it means? If you assume that this is true, then what that means? That means that this Qxy, this is always true for every pair. Yes or no? Can I say this is always true for every pair? Yes or no? This is always true for every pair. Agree or not? For every pair, this is always true. Do you agree with me? Because this statement is saying for all X, for all Y, Qxy. So this Qxy is always true for every pair. This correct or not? Okay. So this is what I am saying, that this will be, from this I can say Q is always true. This Q, this is always true. Always true. For every pair, whatever pair you take. Okay, now you can easily see that if this is always true, if this thing is always true, then this thing is true. Okay, then you can see in the implication, if the LHS is true, if the RHS is true, alpha implies beta. If this is true, then what can you say about the implication? What can you say about this entire thing? What can you say about this entire thing? This entire thing will be true. Okay, if the RHS, if this in the implication, if this RHS is true, then the entire thing will be true. So here you can easily see that if this Qxy is true, if this is true for all the pairs, if this is always true, then definitely in this implication this will be always true, and so automatically this expression will always be true. Yes or no? So this is always happens. So I hope this point is clear. Is this point clear, that this option will be correct? So final conclusion, that this option means if you have this option for all X, for all Y, Qxy, this option is correct. Okay, so this option is definitely correct. This option implies the expression E. If this is true, if this is true, then E will be true. Okay, then E will be definitely true. So this option is correct. Okay, this is your first option. The analysis we have done, you can easily see that in this option, if this is true, then Qxy is always true for all X, for all Y, Qxy. So if you assume that this is true, then definitely this Qxy will always be true. And if this is always true, then in this implication, this RHS is true. So that is the reason I can say this complete expression will be always true. Okay. This is your option number 1. What is the option number 2? Let's do the discussion of option number 2. The option number 2 is like this. There exists a y, or I can say, let me see the option number 2. The option number 2 is there exists a y for all x. Okay, so let's see this. Let's see this one. There exists a y for all x such that px implies qxy. This is the statement. Now what this statement is saying, please understand what this is saying. This is saying that, consider this statement. What this statement is saying? This statement is saying that there is someone. Okay, so let me assume there is someone. For example, let me assume 5. Okay, there is someone in the natural number. The domain is set of natural number. There is someone for all 1, 2, 3 and so on. Okay, there is someone for all, like for everyone there is someone. For everyone there is 5. So there is someone. So let me assume that is 5, because the question is saying this option. Look at this option. This option is saying there is someone. So let's assume that is 5. Let me assume that that is 5. For everyone, okay, for everyone you are saying that, what you are saying, if any of them, like if any of them satisfy P, okay, if any of them satisfy P, for example, if you have this, let me assume this n you have. Now you are basically saying that if n will satisfy P, then what will happen? Then this n comma 5 will be there. Okay, this 5 will help. Is this clear? So now you can easily notice. That this expression will be true. This will imply the expression. The given, this is given to you. Okay, this option is given to you. This option will imply the given expression. Why? What is the reason? Because in this you are saying that this 5 is for everyone. This 5 is for everyone. Means if you study, then the 5 will help you. Okay, if you study, 5 will help you. So let me tell you side by side. If you study, 5 will help you. See, in this option, what this option is saying, this option is saying that if you study, 5 will help you. Okay, 5 will help you. If you study, 5 will help you. Correct? If you study, 5 will help you. And what this expression was saying, the given expression, what this expression was saying, this given expression was saying that for everyone, if you study, then someone will help you. Okay, so if you study, someone will help you, right? If you study, someone will help you. Someone will help you. So tell me, who will imply whom? Tell me, who will imply whom? So this statement is saying that if you study, 5 will help you. And here you are saying, in the expression you are saying, if you study, someone will help you. So you can notice, if you study, 5 will help you. This implies this. Okay, this will imply this. So this option, I hope this point is clear, because you are saying that if you study, 5 will help you. This 5 is going to help you if you study. And the given expression is, so this implies this. So that is also correct. So this option is also correct. Okay, this option, that is also correct answer. Now let's see the next one. What was the next option? There was one option, something like that. See, there was a third option. In the third option you have, see, there exists x, px, and there exists y, qxy. Okay, so there was this option. There exists x, px. So you can check it. You can see there exists x, px, there exists y, qxy. So this option was there. Now let's see this option. What this option is saying. This option is actually not correct, because what this option is saying, please see this option. This is saying that there is someone for whom P is satisfied. Okay, and there is someone for whom P is satisfied, and there is someone such that qxy. Means actually what is happening here, let me tell you why this option is not correct. Consider this scenario. I am giving you a scenario. Let me assume that for this x equal to 5, let's assume P is true. And let me assume that Q 5, 6 is also true. Let me assume that this scenario. Okay. But you also consider that, let's assume for 4x equal to let's assume 4x equal to 9 or 4x equal to 10. Let's assume p is true. Okay, and let's assume this is never true. Let me assume that this is never true, that basically this q8 comma anything, q8 comma y, this is never true. This is never true. Now in this scenario what will happen? Tell me. In this scenario, can you see in this scenario what will happen? See, in this scenario this option will be true. Look at this scenario. Let me call this scenario S. So in this scenario, in scenario S, this option will be true. This option will be true in this scenario. Why? Because you can easily see there exists x for which p is true, and there exists a y qxy. So you can notice there exists x. Yes, 5 is there. Okay, there exists x, 5 is there, and you can notice this expression will be true because for 4x equal to 5, p is true. So you can notice that in this scenario this is true, but in this scenario expression is false. In this scenario, in scenario S, this is true, but in scenario this is false. This is false. So you can easily see that this option does not imply. Actually what this option is saying, please understand what this option is saying. This option is saying that there is someone who satisfies P, and for him there is someone. See what this is saying. This is saying that there is someone. This is saying that there is someone who studies. There is someone who studies. Please understand what this is saying. This is saying there is someone who studies, and for him, and for it, there is someone who studies, and for it there is someone to help. There is someone to help. Okay, but remember, this does not mean that for everyone this will happen. Correct? This option does not imply E. This option does not imply that for everyone this will happen. Okay, very simple. So this option is not correct. What about the next option? There was another option where you have for all y. Okay, where you have this some type of option was there where you have this option. Okay, so let me check whether this option is correct. So there exists x, px, and for all y qxy. Okay, so this option was there. Now let me check if this option is correct or not. See, this option is saying that there is someone for whom this q will be p will be satisfied, and for all y this is happening. See what is happening here. Here this is saying that there is someone. Let's assume that is 5. Let's assume that is 5. And for this p is true. For this p is true. Okay, for this I can say that for this 5, I can say that p is true. Now for this 5, whatever y you take, whatever n you take, what is happening? This 5 comma n is also true. Okay, so everyone is helping 5 here. See, actually here what is happening, that everyone is helping 5. Everyone is helping 5. But it does not mean that everyone is being helped. See what I am saying. What I am saying is, consider this scenario. Again, I am giving you a scenario. Consider this scenario. Consider this scenario that this P5 is true. Okay, this P5, this is true. And let's assume that 5 comma y, whatever you do, that is also true. Okay, for all y. For all y, let me assume. Okay, so this is the scenario. But let me assume that for you assume 6. 6 is also true. Let's assume 6 is also true. But this is not true. What is not true? This is never true. Like no one is helping 6. Okay, let's assume no one is helping 6. So for all y, again for all y, no one is helping 6. Now you can easily see that in this scenario, if you consider this entire scenario, in this entire scenario, this option D is actually true, but the expression is false in this scenario because no one is helping 6. Please understand, no one is helping 6. There is no one who is helping 6. Actually, everyone is helping 5. Everyone is helping 5, but no one is helping 6. So in this scenario, option D is true and option the given expression is false. So please let me know, did you clearly understand this question? This was a very nice question. I hope you understood this. Please let me know. Did you understood this? Did you understand this question? Did you understand this question? So for this question, there are 4 options. And for this question, 2 options are correct, 2 options are wrong. So let me just tell you that finally, these 2 options are correct, these 2 options are wrong. So in this question, the answer will be, this option will be correct answer, this option will be correct answer, this will not be correct answer, this will not be correct answer. Okay, so for this question, these two options are correct. Let me know, did you understand this? This question, did you understand? Let me know. So this is the answer. Okay, these 2 options are the answer. The remaining 2 options, these are not correct, these are wrong. So let's move on now. Shall we go to the next question? Did you do this correctly, Himanshu? Himanshu, did you do this correctly? Let me know. So now let's see the next question. The next question was on the greedy coloring. On this greedy coloring algorithm, this next question is there. So what about this greedy coloring algorithm? So this question was there, if you remember, that a graph was given to you, a simple finite undirected graph was given to you in which you have n vertices. So the number of vertices were like this: v1, v2, and so on, vn. There were total n vertices. Okay, and in this question there was a greedy algorithm that is given to you. This greedy algorithm that was given, let me tell you, this greedy algorithm was something like this. For coloring the graph, n vertices are already given to you, and maximum degree was given to you. The maximum degree was given to you, that was delta. This maximum degree was delta. Okay, now the question was saying that there is a greedy algorithm. In this greedy algorithm, what you do, basically you take any vi, take uncolored vi, take any uncolored vi, just that is uncolored yet. Okay, uncolored vertex vi you take. Okay, or vj or vi, whatever. So what you do, and these are the colors, actually these are the colors that are available. So the question was saying that these are the colors that are available, like 1, 2, 3, 4, and so on. These are the colors available. So these are the colors available. We have these colors available in this question. Okay, actually have you seen Go classes graph theory course? Go classes chromatic number graph coloring lecture, have you seen? This question has already been done. This greedy algorithm I told you, and I told you all these options. Basically I told you that this greedy algorithm does not give you the chromatic number. This we have already seen. In the, you can check it out on the Go classes YouTube channel. Complete graph theory is available. Okay, complete graph theory course by Go classes is already available on the Go classes YouTube channel. You can check it out. Okay, so in that course you watch the graph coloring video. In that graph coloring video, I have told about this greedy strategy, this greedy algorithm I have told, and I told that this will not give chromatic number. This greedy algorithm will not necessarily give chromatic number. Okay, and the now, and we have also seen this. I will prove it. You can easily prove it, that number of colors will be maximum delta plus 1. And this procedure will give vertex coloring. Yes, this procedure will give proper vertex coloring. Means it will definitely give you proper vertex coloring. 2 adjacent vertices will never get the same color in this procedure. Please understand. In this procedure, two adjacent vertices will never get same color. But remember, it does not mean that it will give you the minimum number of colors. So this will give you proper coloring. Means 2 adjacent vertices will never get the same color. So okay, so your proper coloring, that requirement will be satisfied, but you will not get minimum number of colors. Sometimes you can get, sometimes you will not get. So in this question, the answer is actually, these are the answers. That number of colors that will be used is delta plus 1. Okay, and maximum number of colors that you will use in this algorithm, that will be delta plus 1. Maximum degree plus 1. This is the maximum degree plus 1. And this procedure will give you proper vertex coloring. This is the answer. Option 1 and option 2 are not the answer. Let me explain. So this greedy algorithm was given in this question. Take any uncolored vi, okay, and then to this what is the color you are giving to vi? The color you are giving is minimum of all the available values. Basically minimum of all the available values. Minimum of all the available values. j is a color not given to any adjacent vertex, not given to any neighbor of vi, any neighbor of vi. Okay, so this was the question. Basically, among all the available colors, what is the minimum color you can give? Among all the available numbers, what is the minimum number you can give? Okay, so this algorithm is something like this. For example, if you have a graph a, b, c, d, some graph, let me give you, let me assume that you have this graph. Then this algorithm is something like this. You start at any vertex. For example, at this vertex you start, and these are the colors that are available. 1, 2, 3, and so on. These are the colors available. You always give the minimum possible color. Always give the minimum possible color. For example, the minimum possible color is 1, you give it. Then take this vertex. For example, take this vertex. To this vertex you can give minimum possible color, but you can notice you cannot give 1 because that is given to its neighbor. Okay, so give the minimum possible color. Give the minimum available color. So this 1 is not available. The reason is very simple, because this D is neighbor of A. You cannot give the same color to the neighbor vertices. The question is very simply saying that give the minimum color which is not given to any of the neighbors. So to this vertex you can give the minimum color that is available, that is 2. To this vertex you can give the now minimum color available is 1 because these are not adjacent. So for this vertex the minimum color available is 1. And for this vertex the minimum color available is 3. So like this it will happen. Okay, this greedy algorithm will work like this. Okay, clear? So let me know. Very simple. This greedy algorithm actually works like this. I hope this point is clear. Okay, so like this. Now you can easily see one thing. Let me prove one thing, that if you have delta color, see, just think about it. Let's assume the maximum degree is delta. Maximum degree is delta. So you have, let's assume this is your vertex, and this vertex has the maximum degree delta. Let's assume you have a vertex A, and this vertex A has maximum degree delta. Means this has delta neighbors, right? Correct? This will have total delta neighbors, V1, V2, V3, V4, and so on, V delta. Total delta neighbors will be there. Okay, so this vertex A, this has delta neighbors. Now you tell me, in the worst case, what color you will give to A? In the worst case, what color you will give to A? Tell me, in the worst case, which color will you give to A? In worst case, okay, in the worst case, which color you will give to A? Which color we will give to A? Please tell me. Which color we are going to give to A? In the worst case, which color we are going to give to A? And the answer will be C. In the worst case, this can happen. See, we will give the minimum available color, right? We are always giving the minimum available color. In this greedy algorithm, what we are doing? In this greedy algorithm, we are giving minimum available color. Okay, minimum available color. We are giving minimum available color. What is the minimum available color that is possible? Okay, like for example, this is the minimum number. So like this. Now you tell me, in the worst case, which color you will give? In the worst case, it can happen. Please understand that, because this has delta degree. This vertex has A. Let's assume that A has delta degree. This vertex A. Let's assume vertex A has delta degree. Means there are delta neighbors. Total delta neighbors are there. You can see there are total delta neighbors. In the worst case, what can happen? In the worst case, this type of situation can happen, that maybe this has color 1, this has color 2, maybe this has color 3, this has color 4, and like this has color delta. So tell me, in the worst case, what color you will give to A? Please tell me. Let me know. In the worst case, this can happen that all the neighbors have different colors. This is the worst scenario. In the worst case scenario, this is the scenario that in the worst case, all these people have different color like this. This has color 1, this has color 2, this has color 3, this has color 4, and this has color delta. So now you tell me what is the color you will give to A? So that will be delta plus 1. You can easily see that you will never give more than delta plus 1 to any vertex. Whatever vertex you take, you will never give more than this color. This is the worst case color you will give, because in the worst case it can happen that all the neighbors of this A have different colors from 1 to delta, because that is the maximum degree. So this is the situation of worst case, that all the neighbors of A have different colors from 1 to delta. So what is the color you will give to this A? That will be delta plus 1. So that is the reason you can see this delta plus 1 is correct. Okay, and you can also give one example. For example, consider this A, B, C. Consider this example. In this you can notice this has, what is the okay, so let's assume there is a D and there is a D. Now consider this example. In this example, what is the maximum degree? The maximum degree you can easily notice, that will be 3. The maximum degree is 3. So that is delta. Delta is equal to 3. But if you color this using this algorithm, then what will happen? Let's assume you start here and you give this color number 1. Then you go here. Then the minimum available color is 2. You go here. The minimum available color is 3. Now you can easily see that the minimum available color for this is 4. So in this algorithm, you can very easily see that this at most delta color is wrong. At most delta color, that is wrong. That is wrong. Okay, delta plus 1 is correct. At most delta plus 1 is correct. And this is the proof. I have given to you the proof that in the worst case, this is the situation possible that this vertex has all the different neighbors. All the neighbors have different color from 1 to delta. So for this question, you can easily see the answer will be option C, D. Let me tell you that this greedy algorithm can never give you the sometimes this greedy algorithm does not guarantee chromatic number. Please understand, this greedy algorithm does not imply optimal solution. Does not imply optimal solution means does not imply chromatic number. Does not imply chromatic number. The reason is, actually, let me tell you 2 reasons. First reason, you can easily find the counterexample. Okay, if you want the counterexample, you can watch Go Classes Discrete Mathematics course, Graph Theory course on the Go Classes YouTube channel. Okay, so there is a on the Go Classes YouTube channel, there is a playlist, Graph Theory. In that Graph Theory, you can just go to the graph coloring lecture. Okay, you can search Go Classes Graph Theory lecture, Go Classes Graph coloring lecture. Okay, Go Classes basically Go Classes Graph Theory graph coloring lecture. So in that you can easily find many examples where the greedy algorithm will not give you the chromatic number. Let me tell you another reason. The another reason is, let me tell you like this. If this greedy algorithm gives you optimal solution, then what will happen? If this greedy algorithm gives optimal solution, what will happen? Let's assume that if this greedy algorithm gives optimal solution, means if this gives chromatic number always, okay, then what will happen? Then what problem will happen? So let me tell you the problem. If this greedy algorithm gives you chromatic number always, then what will happen? Then you will win. Then P will be equal to NP. So this is an open problem of computer science. This is not in the GATE syllabus, but let me tell you, this is $1 billion question. This is $1 billion open question. What it means? It means that if you prove it that P equal to NP, then you will win $1 million. You will win these many. $1 million you will win. Are you getting my point? If you can prove P equal to NP or P equal to not equal to NP, either you prove this or you prove this. If you can do that, then you will win 1 million US dollar and also the PhD from all the universities. Like whatever university you want, MIT, Stanford, IISc, IIT Bombay, whatever university you want, you can get PhD from that. So you can see that actually this greedy algorithm, if this gives you chromatic number always, then this P will become NP. Okay, because this coloring is a NP complete problem. Let me tell you, finding chromatic number, this finding chromatic number, this is actually NP complete problem. This is a NP complete problem. Okay, and if you can give some easy solution for this, like this greedy algorithm, if you can give a polynomial time solution for this, if you can give polynomial, time solution, polynomial time solution will imply P equal to NP. Okay, is this clear? For this problem, polynomial time solution will imply P equal to NP. So again, you can easily notice that, of course, this greedy algorithm does not guarantee chromatic number. Anyway, counter examples you can easily create. Many counter examples you can create. As I told you, on the YouTube you can search Go classes graph coloring lecture. Okay, or you can go to the Go classes graph theory playlist. In that playlist you can find graph coloring lecture. There you can find the detailed discussion on this greedy algorithm. I have already given the discussion of this greedy algorithm. I have already told this delta plus 1, at most delta plus 1. I have already told that this will give you this will not give you chromatic number. This may or may not give you chromatic number. For some graph it can give you, for some graph it will not give you. Okay, so this may or may not give you chromatic number. This also I told you. Also I told you that this will definitely do the proper coloring, means the neighbor vertices will never get the same color. So all these things you can watch on the Go classes YouTube channel in the graph theory playlist. Okay, so for this question the answer is going to be, let me tell you, as I told you, for this question the answer will be number of colors used is delta plus 1. Yes, that is correct. So this option 3 is correct. And this procedure will give proper coloring. That is also correct. Okay, chromatic number, this option is wrong. And at most delta, this option is wrong. These two options are wrong. Let's move on. Let's see this question. There was a group theory question. A beautiful group theory question was there this time, group theory. So actually what was the question? Let me tell you. The question was something like this, that there is a set. There is a set. Okay, let me assume that the set is A, or maybe the set is S. Then you have the power set of S. There is a power set of S. On this power set of S, you are defining this operation. You are defining symmetric difference. Correct? This symmetric difference you were defining. This symmetric difference means A symmetric difference, this delta, this delta. So this symmetric difference was like this: A minus B union B minus A. So this symmetric difference you are defining. Okay. Now, so in this, what will happen? So the question is actually asking, what is this? PS means on this power set, you are defining this symmetric difference. The question is asking, is this a group? One option is this a group? The second option is, what is the inverse of any element? In this group, what is the inverse of any element? In this group, inverse of element. What is inverse of element? And there was one more option, that it is not a group. Okay, there was one more option, that it is not a group. There was one more option. So these some options were there. Let me discuss this. Actually, this is a very easy question. You have a set S. Okay, then you have a power set. Power set means set of subsets. Correct? This is basically collection of subsets of S. This is collection of subsets of S. Okay, on this you are defining the symmetric difference. This was a very easy question actually. On this you are defining a symmetric difference. Now you can easily see that the symmetric difference, this will be closure. Closure property will be satisfied, correct? The closure property will definitely be satisfied because for this set S, all the subsets you have, collection of all the subsets. For this, all the subsets are there in this PS. So the closure property is satisfied. If you take any two set, for all A comma B, what will happen? That their symmetric difference, if you take, that will belong to P of S. Okay, if you take this, then that will belong to P of S. What is the second option? So the closure property is satisfied. Associative. Symmetric difference is associative. Many times we have seen this type of questions we have done in the set theory. The symmetric difference is associative. Means if you have A delta B delta C, so whether you do this or whether you do A delta B delta C, whether you do this, both are same. Symmetric difference is actually associative. So associative property is also satisfied. What else? What else? The third property. Is there any identity element? What do you think? Is there any identity element? Do we have any identity element in this? Let me know. Is there any identity element in this? The answer is yes. There is identity element in this, and that identity element is phi. Because if you do A symmetric difference phi, that will be A. Okay, A symmetric difference phi, that will be A. Similarly, phi symmetric difference A, that will be A. So that will always happen. This identity element is there, and that identity element is phi. So this phi is the identity element. What else? P of S delta. What else? The fourth property. What about inverse? Inverse means if I give you a set, then what should I put here? If I give you a set, what should I put here such that you will get phi? Can anyone tell me what should I put here such that you will get phi? What should I put here such that you will get phi? Should I put A complement? Should I put A complement? A complement. Should I put that? No, because if you do this, this actually will be S itself. This will be S, not phi. So please understand that if you put this asymmetric difference A bar, asymmetric difference A bar, that will be S, that will not be phi. Asymmetric difference A bar, that will not be phi, that will be S. So what should I put? Yes, A itself. Very good. If I do A symmetric difference A, that will be phi. Asymmetric difference A, that is going to be phi. If you put A symmetric difference A, that will be phi. So you can easily see, and this is commutative also. So basically this is the final conclusion, that there is a set S and you are defining this operation on PS, this symmetric difference operation you are defining on PS. Now you can easily see all the properties are satisfied. The closure property satisfied, associative property satisfied, identity element satisfied, that is phi, inverse property satisfied, A inverse is equal to A for all A in PS, for every element in PS. Okay, for every element in PS, A inverse will be A. A inverse will be A itself. And this will be commutative also. This will be commutative also. You can notice this symmetric difference is commutative. So this is actually a abelian group, right? This is actually a abelian group. This is actually a abelian group. So for this question, the answer will be that it is a group. So actually, let me tell you that for this question, the answer is, for this group theory question, the answer will be, there will be two options will be the answer. For this group theory question, one option will be it is a group. It is a group. Second option will be that every element inverse will be itself. Every element is inverse of itself. These two options will be correct. Okay? For this question, these two options will be correct. Clear to everyone? Let me know. These two. So this is your group theory question. Very simple question. Let's see the next question. There was a permutation combination question. Do you remember that? Very nice question. Very beautiful question. There was a permutation question. One permutation question was there. Let me tell you. The question was something like this: that you have total. You have a set. You have a set S with n elements. Okay, n is very large. This n is something like very large. This n is greater than 1000. This was given in the question. N was very large. Okay, this was given in the question that n is very large. Actually, let me tell you that this does not matter. Actually, see, I think they have given this so that you don't put the value of n. They gave you this option. They gave you this just so that you don't put the value of n. Actually, this was given. This was given only so that you don't put the value of n. So that students don't put the value of n. Students don't put value of n and solve. So they just wanted you to actually this does not matter. Let me tell you, this was irrelevant. This is irrelevant. Is this clear? This detail was irrelevant. This n can be 10, 5, 6. It will not change. The answer will not change. In this question, this detail was irrelevant. This n is greater than 1000. This information was given. Do you remember? In this question, this information was given. And this information, I think, they gave this information so that students do not put the value of n and solve. Because there were 4 options. Because this question was MCQ question. This was a MCQ question. So they wanted that a student does not put the value of n. A student does not get the answer easily. So that is the reason this irrelevant statement is given. This statement was irrelevant. You will see. I will give you the solution. This statement is irrelevant. Anyway, also some number k is given to you. K is greater than or equal to 1, less than n. Some number was given to you. Okay, this number was given to you. And the question was saying that there are 2 subsets of A. There are 2 subsets of S such that their intersection is 5, they are disjoint, and their cardinality is K. Okay, so this was the given information. In the question, this was the given information that you have a set S which has total n elements. N is very large, n is greater than 1000, and there is a number K which is less than n, greater than equal to 1. There are 2 subset of S which are disjoint, and that is equal to K. Okay, which are disjoint, and that is, their cardinality is equal to K. So what is happening here? Actually, it is happening. See, this is your set. Your set is 1, 2, something like this. This is your set 1, 2, 3, and so on. This is your set. In this set, there is a set A. There is a subset A, and there is a subset B. Please understand. Please understand. There is a subset A. There is a subset B. This also has K elements. This also has K elements, and they are disjoint. And they are disjoint. Means A, B, they are disjoint. Are disjoint. Okay. Now you can see that the question was asking how many permutations. If I directly ask you how many permutations, what will be the answer? If I directly ask you without any condition, if I ask you how many permutations, what will be the answer? Please tell me. If I directly ask you what is the number of permutation, what will be the answer? That will be n factorial. Answer will be n factorial if they ask you directly, but this was not the answer. The reason is they are saying that you have to give the permutation where A, B are separate. Number of permutations where A, B are separate. Separate means there, okay, the question is asking where the permutations. You find the number of permutations where A, B are separate. They are separate. What this means? This means that in this question, it means that if elements of A are here, see, if these are the elements of A, if in this area you have elements of A, so for example, this is your complete area. This is your complete area. If in this area you have elements of A, then in this area you should have elements of B. Means if this is the area of elements of A, then this should be the area of elements of B. Okay, they must be separated. They must be separated. They should not be mixed. The last element of A should be before the first element of B. Okay, so actually in this question, the question was saying something like this. Let me tell you that this set is given to you in which you have total n elements. Total n elements. And I told you that there are two subsets of S. There are two subsets of S which are disjoint. A comma B are disjoint and they have the same number of elements. And the cardinality of A is equal to cardinality of B is equal to K. And what the question was asking that this A comma B must be separate. The last element of A, okay, either separate, A comma B must be separate. Permutations with separate A comma B, okay, with A comma B separated. What that means? Separated. What that means? That means last element of A before first element of B, okay, means your basically in the permutation last element of A must be before first element of B, must be before first element of B, first element of B, correct? Or vice versa, or vice versa, means last element of B must be before the first element of A. So in the, how to solve this question? The answer is very simple. What you can do? So basically number of permutations, how to find that? What you have to do? You have to separate A comma B, right? Number of permutations with A comma B separate. This is extremely easy question, let me tell you. Now we will see the solution with A comma B separate. So here what you can do? Number of permutations with A comma B separate, what you can do? Basically the remaining elements first of all you select, there are total n positions, right? Okay, there are total n positions. You have total n positions are there. In these n positions, first you select 2k position for A comma B. Okay, just select 2k positions for A comma B. 2k positions. You select 2k positions for A comma B. For A and B, you select 2k positions. Now once you select 2k positions, then what you can do? So this is what we are doing. Total n positions are there. The permutation of S, because we want permutation of S, in that there are total n positions. There are total n positions. You have total n positions. Now what you do? In these n positions, you select 2k positions. These red are the 2k positions. Okay, for the, so something like this. These red are the, actually what are these red? These are for A comma B. For A comma B, these red. Okay, so these red arrows, like this red arrow, this is for A comma B. Now what you can do? From the n elements, you can select 2k positions for A comma B. This is what you can do for A comma B. Okay, the remaining elements can arrange, right? The remaining elements can arrange in any order they want. The remaining elements, they can arrange in any order they want. This is for remaining. Okay, the remaining elements, they can arrange, they can permute in any order they want. This is the remaining elements n minus 2k factorial. This is the permutation of the remaining elements. The remaining elements can arrange in any order they want. Now what we have to do? Now you have to do, see, there are 2k positions. Now there is nothing. Now there are 2k positions. You can notice these red positions. These are the 2k positions of A comma B. These are your 2k positions of A comma B. Now you can notice that if A is coming before B, then the first k positions, you can easily see that, you can easily see two things can happen. Either this will happen or this will happen. Either this will happen that, okay, A will come first, then B will come, or this will happen, that B will come and then A will come. Okay, so either this will happen or either this will happen. So now you can notice that, now you can easily see, so these are the K things, these are the K positions, these are the K position, these are the K position, these are the K position. Now you can easily see the answer will be that these A people can arrange in K factorial ways and these people can arrange in K factorial ways. So you can note these people can arrange in K factorial ways and these people can arrange in K factorial ways. Similarly, double. So the answer will be actually double of what we calculate here. So the answer is going to be the K factorial whole square and this multiplied by 2. Why multiplied by 2? The multiplied by 2 because either A followed by B or B followed by A. Okay, either A will be followed by B or B will be followed by A. Either this A will be followed by B or B will be followed by A. So for this question, the answer will be into 2. Is this point clear to everyone? Let me know. So this is a simple, very simple question. I hope you understood. The question is actually very simple. A set is given to you. In this set, total n elements are there. Total n elements. 1, 2, 3 and so on. Total n elements are there. Some elements are these K elements. These are the K elements and these are the A. These are the set A. And these are the K elements. These are set B. Okay, these K elements are set B. Now now what the question is saying? The question is simply saying that how many permutations will be there? So the answer will be, let me tell you the answer will be either A followed by B or B will be followed by A. Okay, either this will happen or this will happen. Now if you take A followed by B, then the answer will be that from the n positions, the 2K positions you select for A, B, the remaining people can arrange in n minus 2K factorial ways. This is for the remaining people. And then these A people can arrange in K factorial ways and these B people can arrange in K factorial ways. Okay, so please understand that this is for A, B. For A, B, you are selecting 2K positions. This is for remaining. This is for remaining. And understand that this is for A. A people can arrange in K factorial ways. And this is for B. B people can arrange in K factorial ways. And the same value will be here. The same value will come here. The same value will come here. So the answer will be, final answer will be double. Okay, so let me tell you the final answer. The final answer of this question will be 2 multiplied by, this will be the final answer, 2 multiplied by NC2K multiplied by n minus 2K factorial multiplied by K factorial whole square. This will be the answer. Okay, very simple, right? So this was another beautiful question from the permutation combination, from the combinatorics. And this is the final beautiful question, equivalence relation and surjective function. Anyone remembers this question? Equivalence classes, some question was there, equivalence class, surjective function was given. Okay, this was a very beautiful question actually. And similar question we have done in the Go classes test series also. If you check, I think you can check mock test 7. In the mock test 7, similar question was there. Not the exact, but very similar question was there in the mock test 7. Anyone remembers? In the Go classes test series, mock test 7 had similar question. Very similar question we have already given in the mock test. We were asking for number of equivalence classes. Some question I was asking, in the question surjective function was given, equivalence relation was given, something was given. Anyone remembers this? This question do you remember? In the Go classes mock test 7, we had what we had given? We had given surjective function. This information we had given, and we defined one equivalence relation, and we were asking some options based on the question. Okay, anyway, let's see this question. This is a beautiful question. Let me explain what is happening here. So this question was this, that there is a set A, set B. There is a non-empty set. The question was this, that there are non-empty set A, B. Okay, you have non-empty set A comma B. You are defining a onto function. You are defining an onto function f from A to B. Okay, you are defining this onto function from A to B. Then what you are doing? Then you are defining a relation. Then you are defining an equivalence relation. Then you are defining equivalence relation R on F. This equivalence relation you are defining on number of functions. How many functions are there? Okay, so basically this onto function is there. On A. On A, you are defining this equivalence relation. You are defining on A, and you are defining like this. You are defining like this, that A is related to B if and only if they have the same images. FA and FB are the same if they have the same images. So this equivalence relation you are defining. Because you have equivalence relation, so there will be equivalence classes. Correct? There will be equivalence classes. Now the beautiful question. See, actually in this question what they are doing. So there will be equivalence classes. Let's assume this is the set of equivalence classes. Let's assume that this E is the set of equivalence classes. Set of all equivalence classes. Set of all equivalence classes. Okay. Now the question is defining a new function. Now the question is defining a new function. See, there are many twists and turns. Correct? A new function the question is defining. A new function. The question is saying that let's define a new function f from E to B, defining a new function. You are defining a new function and you are saying that, or maybe that can be G, like whatever you want, that can be G. So a new function you are defining from equivalence classes to the same B, to the same B. And you are defining like this, that GE will be for any element. Like in this, if you have some element, in this if you have some element, for example, in this if you have some element E, then this GE will be equal to, this will be equal to some element Y. Okay, this will be equal to some element Y if so this is some equivalence class. Okay, this is some equivalence class. Let us actually, this is some equivalence class. In the question, for example, I can say this is some equivalence class like this, something like this. For this equivalence class, the answer will be Y if f of A is equal to Y. Okay, this was given if f of A is equal to Y. So something like this was given. Let me explain actually. I know you are getting confused, but let me explain what this question is saying. Let me take one example and let me explain what this question was actually saying. Let me take a small example just to explain this question. Please find this. This will definitely explain this question. Let me assume that you have this function. Let me assume you have set A. Your set A is 1, 2, 3, and this is your set B. And this set B is, let's assume A, something like anything. For example, maybe A comma B. Okay, let me give you surjective function. So consider this surjective function. This is a function f, because the question is saying that you have a surjective function. The question is saying this is a onto function. So I have given you onto function. Okay, onto function I have given you. Now the question is saying that you are defining an equivalence relation. What you are defining? You are defining an equivalence relation. And you are saying that on A, equivalence relation you are defining on A. Please understand. On this A, you are defining the equivalence relation. And you are saying that two elements, X will be related to Y if and only if they have the same image. If they have the same image, then they will be related. Now, let me tell you that. So here you can easily see that 2 will be related to 3, correct? 2 will be related to 3 because they have the same image. You can notice F2 is equal to F3. So they are related. Now, because you have an equivalence relation, so there will be equivalence classes. Tell me what are the equivalence classes here? There will be equivalence classes, and that will be one equivalence class will be for 1 and another equivalence class will be for 2. Remember, this equivalence class is same as this equivalence class. They are basically same. Okay. So what I am saying that this function is given to you. So finally you got these equivalence classes. You got two equivalence classes. There are two equivalence classes. One equivalence class is for element A, and another equivalence class is for element 2, element 1 and element 2. Actually, this equivalence class is same as this equivalence class because they are related to each other. 2 is related to 3, 3 is related to 2. So actually there are two equivalence classes you can consider. So ultimately there are two equivalence classes. Now what the question is saying, the question is defining a new function. Question is defining a new function. In the new function, what they are saying that basically from the equivalence classes, okay, this is your set of equivalence classes. These are the set of equivalence classes. Please understand, this is the set of equivalence classes. So from the equivalence classes to the B, to the same set B, your same set B, this same set B, okay, and you are defining like this. This one will be related if F1 is 1, F1 is A, because we know F1 is A, F1 is A, and F2 is B, so this will be related to this. So this is your new function. Okay. Now the question is asking this new function is what? Okay, what this question is asking? Let me tell you. What this question was asking. This new function will be what? This new function will be bijective. Will this new function be bijection? Will this be 1-to-1? Will this be on-to? Will this be on-to? And there was not well defined. Not well defined. So here the answer will be, let me tell you, this new function, you are waiting for the answer, I know. This new function will be bijection. Automatically it will be 1-1. Automatically it will be on-to. And I will discuss this. Do not worry about it. I will discuss this. But every function by definition is well defined. See, every function, by definition, every function is well defined. So actually this option will not be correct. I will tell you, I will discuss what is this well defined function. But every function by definition, this function is actually well defined. There is no problem. In this function, there is no problem. Everything is well defined. So for this question, the answer will be bijection, 1-1, on-to, everything. Let me tell you why. What is the reason? The reason is actually very simple. Did you understand the complete flow? What is happening? You are defining what and what. From the starting to end, what you are defining. So initially you have a surjective function. Please understand, one by one, let's discuss. You have this set A, some set A you have, some set B you have, and the question, what the question is saying that there is a surjective function. You have a surjective function. This F is on-to. Because it is on-to, so every element, for example, let me consider A, B, C. Let me consider A, B, C or D, A, B, C, D. Let me consider A, B, C, D. Now every element has some pre-image, right? Every element will have some pre-image. Because this is a on-to function. Since this is a on-to function, so every element is going to have some pre-image. Okay, for example, maybe this element has some pre-image. This element also has some pre-image. And similarly, this element also has some pre-image. So every element has some pre-image, correct? This is your on-to function is already given to you. Now the question is saying that basically you are defining equivalence relation. Okay, no problem. You are defining equivalence relation on domain. Please understand, on domain A. On this domain A, you are defining, on this domain A, please understand, on this domain A, you are defining equivalence relation. And you are saying that, for example, this is 1, this is 2, let's assume this is 3, this is 4, this is 5, this is 6. Now you are saying basically that because 1 will be related to 2. Why? Because 1 will be related to 2 because F1 is equal to F2. They have the same pre-image. You can easily notice that 3 is not related to 4. 3 is not related to 4 because F3 is not same as F4. Okay, F3 that is not same as F4. Next you can notice that 5 is related to 6. 5 is related to 6. Okay, so this is the concept that equivalence relation is defined. Now because equivalence relation is there, so there will be equivalence classes. If there is equivalence relation, then there will be equivalence classes. Agree? Okay, so there will be equivalence classes. Let me write them. What are the equivalence classes? For this function, what is going to be the equivalence classes? The equivalence classes will be three. One equivalence class will be one. Basically, these two people will create one equivalence class. Okay, one equivalence class, these two people will create. Actually, this equivalence class, if you notice, this equivalence class is basically 1 comma 2. These two people will create one equivalence class. Similarly, these two people will create one equivalence class. This 5, if you notice this 5, that is basically 5 comma 6. These two people will also create one equivalence class. And this person will create another equivalence class in which it will be the only one. So this is the scenario. So you can easily notice these two people are creating equivalence class. This is creating its own equivalence class. This is creating its own equivalence class. So there will be one equivalence class for 3. There will be one equivalence class for 4. And there will be one equivalence class for 5. Okay, is this clear? So there will be 4 equivalence classes. We will have total 4 equivalence classes. Let me write it. I think my video is coming here. So anyway, let me just write it that there will be one equivalence class where 4 will be there. Only 4 will be there. In the equivalence class of 4, only 4 will be there. So there are 4 equivalence classes. Now what you are doing? You are defining a new function. Now you are defining a new function. Remember, you are defining like this: 1, 2, 3, 4, then 5, 6. Now you are defining a new function from equivalence classes to B. From this equivalence classes to B, you are defining a new function. Remember, the equivalence classes are like this. There is one equivalence class for these two people. There is one equivalence class for these two people. There is a separate equivalence class for this person. And there is a separate equivalence class for this person. And this is your ABCD. Now this is saying that this will be related to whom one is related. See, this equivalence class, this equivalence class, look at this. This equivalence class will be related to the person to whom one is related. In F, you are defining a new function G. But in this new function, we are saying that any equivalence class, like for example, in this G, any equivalence class will be related to that person, whom X is related. In F. So what is happening here? This equivalence class will relate to that person who is related to whom one is related. So you can note this will be related to A. This 3 will be related to B. 4 will be related to C. This will be related to D. You will always get a bijection. You are always going to get a bijection because the original function was on to. So actually what is happening here? From the equivalence classes to the set B, you will always get onto. This function will be 1 to 1. This new function will definitely be 1 to 1. What is the reason? Let me tell you. This will be 1 to 1 because, see, two equivalence classes can never go to the same element, right? Yes or no? Like this, in this equivalence class, some elements are there. Definitely these elements are mapping to someone else. And definitely these elements are mapping to someone else. Because if they map to the same element, then they will become single equivalence class. Then they will merge. If this happens, then these two equivalence classes will merge. We will merge them. These two people will merge. So this cannot happen. So this will go to someone else. So this will be 1 to 1. And also this will be on to. Also this G will be on to. Why this G will be on to? Because your original F was on to. Every element has some pre-image in F. So every element will have some equivalence class. Okay, every element is going to have some equivalence class. Because in F, your F was on to. Your original function F was on to. In your original function, every element has some pre-image. Every element in your original function F. Look at your original function F. In the original function F, every element has some pre-image. So that is the reason. In the new function also you can notice every element will have some pre-image, some equivalence class every element will have. So this will be on2 also, this will be 1 1 also. So finally this will be bijection. This is going to be bijection. So it will be bijection, it will be 1 1, it will be on2, and the given function is well defined. The given function that is well defined. This given function has no problem. This given function is well defined. Actually, by definition, every function is well defined. By definition. Okay. I will not go into the detail of well defined, but let me tell you the concept of well defined. There is something called well defined function. Actually, I don't want to go into this because this is really not needed. There is something called well defined function. Well defined function. What is a well defined function? Let me tell you. The well defined function definition is this. Well defined function definition is this, that if A is equal to B, then fa is equal to fb. Now tell me, by the definition of function, can I say every function is well defined? Please tell me. Please tell me. By the definition of function, every function is well defined, because if A is equal to B, if means a element cannot have two images. Basically well defined what it means? Basically well defined what it means? It means what? What it means? It means that same element cannot have two images. Okay, same element cannot have two images. Same element cannot have two images. Please let me know. Did you understand well defined function? What is a well defined function? Did you understand that if A is equal to B, then fa is equal to fb? No, this is not 1 1. Akash, this is not 1 1. 1 1 says that this is the definition of 1 1. Please understand. Please understand, 1 1 function definition is this. 1 1 function says that if A is not equal to B, then fa is not equal to fb. Then fa is not equal to fb. This is 1 1 function. What is well defined function? Well defined function means a function. Well defined function automatically means function. The question is, well defined function automatically means function. Okay, is this clear? Well defined function automatically means function, and well defined function means basically if two people are same, then their images is same. One person cannot have two different images. One person cannot have two different images. So well defined function by definition, that is a function. Is this clear? So the question is basically asking, the four options are, this is not even a function. Yes, this is a bijective function, so it is a function. Is this clear? Let me know. Please tell me. Is this point clear, that well defined function is automatically a function? Every function is well defined function. Okay. No, Akash, this is not a well defined function. Please understand that, Akash, this is not a well defined function. Let me give you example of non well defined function. This is not a well defined function. Akash, this is not a well defined function. This is not a well defined function. So that is the reason I am saying that by default you can easily see function means well defined function. If it is a function, it is well defined function. So finally this is what I am saying. If it is a function, then it is a well defined function. If it is a well defined function, then it is a function. These two things are same. Okay? If it is a function, then it is a well defined function. If it is a well defined function, then it is a function. This is what I am saying, that this is not even a function. Akash, that is what I am saying. Not a function. Or you can say not a well defined function. Please see this. Function means well defined function. Not function means not well defined function. Okay? Clear? So basically this is just to confuse. This terminology is used just to confuse. Basically the question is asking, will it be a function or not? Basically in this question, let me tell you, in this question the question was there, in this question it was asking whether it is a function or not. The four options are given to you. The final answer will be it is a bijection. Okay, so your final answer will be it is a bijection, it is a one to one, it is on to. Yes, it is a function, it is also a function. Okay, it will be a function because some same element cannot have two different images. So this is your answer. This is the complete analysis of discrete mathematics questions. What do you think about the level of discrete mathematics questions? What do you think the level of discrete mathematics questions? Tell me, what do you think? Like in this GATE 2023, what do you think? The TOC was very easy. The TOC was very easy. DBMS was very dumb and easy. DBMS was very dumb and easy. Okay. But this discrete mathematics was very nice, right? Do you agree? This discrete mathematics was very nice, very nice. The discrete mathematics questions are actually very, very, very nice, very beautiful questions. Correct or not? The discrete mathematics questions were very beautiful. Did you understand the solution? Please tell me. Let me know. I have given you the complete analysis of all the discrete mathematics questions. The complete analysis we have seen. I have told you everything about each and every discrete mathematics question. Please let me know. Did you understand my explanation? Whatever I have told you, whatever explanation I have given to you, let me know. Did you understand? Please share your feedback with me. This discrete mathematics, all the 5 questions we have seen, each question is beautiful question. Every question is beautiful question, and for each question we have seen the complete analysis. I have told you the exact logic, what is happening, what is the question, what is the meaning of the question, how to solve this question, how to understand this question. Okay, what will be the answer for this question? Everything I have told you. Please tell me. Let me know. Okay. So you can easily see for this final question, the answer will be, it will be bijection also, it will be onto also, it will be 1 1 also. So these 3 options are correct. Bijection, 1 1, onto, these 3 options are correct, but this option is wrong. Okay. Any other doubt? Let me know. So we will see one more question. But before that, please like and comment on the session. Okay. Please like the session and share with all the GATE aspirants. You can find the part 1, part 2 in the description. Okay. This is part 3. In this session, in this video, we are discussing discrete mathematics GATE 2023 questions. Okay. So basically, let me tell you that in the part 1, what we have done. In the part 1, we have seen TOC questions, we have seen compiler design questions, we have seen operating system questions, we have seen computer organization questions, we have seen DBMS questions, we have seen. These questions we have seen in the part 1. In the part 2, computer network question we have seen, remaining operating system question we have seen, and in the part 3, discrete mathematics questions we have seen. Okay. So we will have the remaining sessions we will have tomorrow. So the part 4, all the remaining questions, everything that is remaining, all remaining questions we will discuss tomorrow. So this part 4 will be tomorrow. Okay. This part 4, this will be tomorrow. Is this clear? So in the part 4, we will discuss each and every question. Each and every question we will discuss. Each and every remaining question we will discuss. All the remaining questions we will discuss. But these subjects we have already seen. Theory of computation, operating system, compiler design, computer organization, DBMS. These we have seen in the part 1. In the part 2, we have seen computer network operating system. In the part 3, we have seen discrete mathematics. And in the part 4, we will see all the remaining questions. But this last question I want to take. This was aptitude question, do you remember? There was aptitude question that fx is equal to gy for all the real values. There was aptitude. In the aptitude, there was one question. This question I want to discuss. That the question was something like this, that fx is equal to gy. Fx is equal to gy for all real values of x comma y. Tell me when it can happen. For all real values of x comma y, fx is equal to gy for all real values of x comma y. When it can happen? So for example, I can say that basically if you take any real value, so I can say f3 will be equal to g2. Okay, whatever real value you take, whatever two real value you take, f3 will be equal to g2, f4 will be equal to g2. Okay, right? I can say this f4 will be equal to g3 also. This f4 will be equal to g3. Basically, whatever real value you take, please understand, for all real values of x comma y, for all real values, like this x comma y, you can take whatever. Like this x, you take anything. This x you take anything, and this y you take anything. What will happen? That fa will be equal to gb. Okay, so whatever you take, this will happen. fa will be equal to gb. So for example, if you take x equal to 4, y equal to 3, then you can notice f4 will be equal to g3. Similarly, if you take x equal to 4, y equal to 2, then what will happen? f4 will be equal to g2. Similarly, if you take x equal to 3 and y equal to 2, then what will happen? f3 will be equal to g2. So tell me what is happening here. Basically what is happening, if you notice, I can prove what I can prove. I can prove that f5 will be equal to f11. How can I prove? Can you prove it? Can you prove it? Can you prove it? Yes, I can prove it. What I can do? See, I know that f5 is equal to g6. And I know that g6 is equal to f11. Okay, right. So basically here what I am doing, here I am taking x equal to 5, y equal to 6. And here what I am doing, here I am taking x equal to 11, y equal to 6. So what I have done, I have proven that f5 is equal to f11. So actually you can prove that it will always happen fa will be equal to fb. It will always happen. GA will also be equal to GB. It will always happen. So ultimately, basically I can say that fx and gx, they all will be same and they will be constant. They are equal and they are constant. They are some constant. They are some fixed value. Yes or no? Then only it can happen. Then only it can happen that basically this f and y, they are fixed value. For example, maybe this point, look at this point. Maybe this is, for example, maybe this is 2. So basically fx is also 2 and gy is also 2. Now you can notice that it will always happen that whatever you put, they will be same. They will be same. So for this question, the answer will be fx equal to gy is equal to constant. Okay, whatever value you take, that will be constant. So for this question, the answer is this. This was a very simple aptitude question. Very, very, very simple question. Did you do this correctly? Let me know. In the aptitude, did you do this question correctly? This aptitude question, have you done this correctly? Let me know. Okay, so let me give you some more answers if you want. There was one stack queue based question, right? Do you remember? There was one stack queue based question. For that, the answer will be 8. We will discuss tomorrow. Don't worry, we will discuss this tomorrow. There was a BFS question. For that, answer will be 7 factorial, which is 5 5040. Okay, so these are some questions from top of my mind. From top of my mind, I'm discussing this. Okay, these are some questions. But anyway, we will discuss tomorrow in detail. All these questions we will discuss tomorrow in very detailed manner. We will discuss all the remaining questions we will discuss. Okay. So do not worry about it. These all these questions we are going to discuss. Anyway, so let's terminate this session now. Again, I am telling you that in this, what we have done, let me tell you. I told you that there is part 1. In the part 1, we have already seen GATE 2023 TOC questions, compiler design questions, operating system questions, computer organization and DBMS questions. In the part 1, we have seen these subject. All these questions we have seen in the part 1. You can check the description. In the description, you will find the link for the part 1, part 2. In the part 2, we have seen computer network and operating system questions. And in the part 3, we have seen discrete mathematics questions. So in this part, in this video, we have seen all the discrete mathematics questions. The complete analysis of each and every discrete mathematics question we have seen. Discrete mathematics has very nice questions in GATE 2023. Okay. So in the part 4, we will discuss all the remaining questions. So tomorrow, there will be part 4, the last final part. Okay. In this final part, we will discuss all the remaining questions. We will do the detailed discussion of all the remaining questions we will do. So that we will do tomorrow. Okay. So again, I am telling you that this part 1, part 2, you can find GATE 2023 analysis and solution. The link is in the description. You can check it out. You can join Go Classes Telegram group. Again, the link is in the description. You can check it out for all your doubt discussions. You can ask all your doubts related to Go Classes courses, related to any technical, non-technical doubt you can ask. Also, if you are preparing for the GATE 2024 course, if you are preparing for the GATE 2024, then you can join the best course for your best preparation. If you want to study all the concepts with proof, if you want to study all the concepts with proper understanding, without rote learning, if you want to study all the concepts with proper, correct, clear, complete understanding, if you want to study all the concepts, all the subjects, then you can join Go Classes GATE 2024 complete course. You can join. The link is in the description. You can check it out. Or you can go to Go Classes website and there you can check it out. So you can start your preparation if you are preparing for the GATE 2024. All the students who are preparing for the GATE 2024, you can enroll now, you can join now, and you can start your preparation. Okay. So you can visit Go Classes website and you can enroll for the GATE 2024 complete course. The link is in the description. Similarly, if you are preparing for GATE 2025, if you are in first year or second year, or if you are preparing for this exam GATE 2025, then you can join Go Classes GATE 2025 complete course. Again, the link is in the description. You can check it out. Okay. Also, I want to tell you that Go Classes Discrete Mathematics and C Programming, these two courses are freely available for all the students. Okay. Complete Discrete Mathematics, complete C Programming, all the lecture, all the homework, all the weekly quizzes, all the annotated notes, everything. So Discrete Mathematics and C Programming, complete Discrete Mathematics, complete C Programming, these two courses are freely available for all the students on the Go Classes website. So you can go to the Go Classes website and you can study Discrete Mathematics, you can study C Programming. For these two courses, you do not have to go anywhere. Complete Discrete Mathematics and complete C Programming are available on the Go Classes website and application. We also have application, so you can download Go Classes Android app. This month, in the month of February, our iOS app will also come. Okay, our iOS app is also coming. So that app also you can download in this month. This will come, but we already have Go Classes Android app that we already have. On the Play Store, you can search Go Classes and you can download. Again, the link is in the description. You can check out the description and you can find the application link. So you can download Go Classes application. And as I told you, iOS application is also coming this month, in the month of February. All the students who are using iPhone, you can download iOS app, Go Classes iOS app also you can download. In this month of February, we will announce. Okay. So thank you everyone. Thank you so much. And please like and comment on this session. Please let me know your feedback, your review. We have seen all the discrete mathematics questions in this session. The complete analysis I told you. What for every question I told you what is the meaning of the question, how to understand the question, and what will be the answer, and what is the complete analysis, what is the logic behind the question. So everything I told you. Please give me your suggestion, your feedback, your review is very important. On the Go Classes YouTube channel, whatever feedback you give, whatever comment you put, we go through that comment. We always go through each and every comment. We consider your feedback, we consider your review. Your feedback motivates us. You also need motivation, we also need motivation. So please motivate us by your comments. Whenever you are watching any Go Classes YouTube channel video, then definitely you will learn something new. Definitely, because in every video we always teach with quality, we always teach with proof, with complete understanding, we always teach. So you will definitely learn something new in every lecture, in every video. So please share your feedback with us. That will motivate us to bring more videos on the Go Classes YouTube channel. Okay, the more you motivate us, the more videos we will bring for you on the Go Classes YouTube channel, more quality videos we will bring for you on the Go Classes YouTube channel. So please like and comment on every session. Please give your feedback about that particular video. Whatever video you are watching, for that video please give your suggestion, your feedback, your review. Okay, we will definitely consider it, we will go through it. Okay, so thank you everyone. Please comment and please like and comment and share. So we will meet tomorrow, and tomorrow we will discuss all the remaining questions that we have not seen so far. As I told you, many questions we have seen already, many questions we have discussed, but the remaining questions we will discuss tomorrow. All the remaining questions we will discuss. Okay, Akash is asking when the remaining questions we will discuss. Tomorrow we will discuss. Okay, tomorrow afternoon we will discuss all the remaining questions tomorrow afternoon. Okay,